Good morning, everyone, and respected ma'am, myself Samiksha Kare from Group Atom Family. On behalf of them, me and my colleague Kunika Sopkar will let you know about the analysis and qualitative test for phenols. So we are going to talk mainly about the qualitative test, begin with the basic introduction of phenol, and then the solubility topic and 5 qualitative tests and analysis of phenols. So let's start with the basic introduction of phenols. Aromatic compound containing one or more OH groups directly attached to carbon of benzene ring are called as phenols. Simplest phenol is carbolic acid. The term phenol is derived from the benzene name phen. Phenyl is equal to C6H5. Then our next topic is solubility of phenols. The solubility of phenol in water is governed by the hydroxy group present. The hydroxy group in phenol is involved in the formation of intermolecular hydrogen bonding. Thus, hydrogen bonds are formed between water and phenol molecules which makes phenol soluble in water. However, the aryl group attached to a hydroxyl group is hydrophobic in nature. Thus, the solubility of phenol decreases with increase in the size of aryl group. So here are the 5 tests. Any of the following tests can be carried out to detect the phenolic functional group. First is litmus test, second is ferric chloride test, third is Lieberman's test, fourth is bromine water test, and fifth is thiene dye test. So here is our main topic, that is qualitative test for phenols. Phenol is one of the most versatile and important industrial organic chemicals. Our first test is litmus test. Scientists use litmus paper to test whether the given solution is acidic or basic. Red litmus paper turns blue while blue litmus paper remains unchanged in the presence of base. Phenol turns blue litmus paper red. This shows that phenol is acidic in nature. Carboxylic acid is also give this test. Compared to carboxylic acid, phenol is weakly acidic and it does not give an effervescence with aqueous sodium carbonate. Our next test is ferric chloride test. Aqueous solution of phenol react with freshly prepared ferric chloride solution give color complex. Most phenol give dark color solution. The chemical reaction is given below. As you can see, it also form violet color complex. The color produced by the simple phenolic compounds with ferric chloride solution is listed below. So the first is phenol, resinol, orthocresol, paracresol gives violet or blue color. Cathecol gives green color, hydroquinone gives violet or translucent blue color, and parogalol gives blue color and rapidly changes to red. Our next test is Lieberman's test. Phenol reacts with concentrated sulfuric acid and sodium nitrate to form a yellow color quinone monozyme complex. With excess of phenol and sulfuric acid, a deep blue indophenol complex is formed. On dilution, a red color indophenol is formed, which turns to deep blue color sodium salt solution of indophenol on treatment with sodium hydroxide. The point to be noted that this test is given by the phenol which contains a free para position. As you can clearly see, here is the reaction of Lieberman test. Thank you and over to you, Kunika.
Now, the further I will explain. The next test is bromine water test. Phenol undergo electrophilic substitution reaction with bromine. When bromine water is added to aqueous solution of phenol, the brown color of bromine disappears and the white precipitate tribromophenol is formed. The chemical reaction is given below. When the phenol is react with bromine, tribromophenol is formed and thus white pipetic form. The next test is thiolane dye test. Phenol on the heating of with thiolane anhydride in the presence of concentrated sulfuric acid form a colorless condensation compound called phenolphthalein. On the further reaction, the dilute sodium hydroxide solution give pink color fluorescent compound called fluorescein. The characteristic color are produced by different phenolic compound which can be viewed under the white background. The chemical reaction are given below. The phenol is react with thiolane anhydride in the presence of H2SO4, the phenolphthalein, which is produced colorless. And now we added NaOH, the pink color will form. The excess NaOH add the colorless compound. form. The color produced by different phenolic compounds in Thailand dietase are listed below. Phenol gives reddish pink. Orthocresol gives red. Metacresol gives blue or violet blue. 1-naphthol green. 2-naphthol gives faint green. Resoquinol gives yellow-green fluorescence. Hydroquinone deep purple. The analysis of phenol. The most characteristic property of phenol is their particular degree of acidity. Most of them stronger acid than water, but weaker acid than carbonic acid. Thus, the water is insoluble compound that dissolve in aqueous sodium hydroxide, but not in aqueous sodium bicarbonate. Is mostly like a phenol. Many, but not all, the phenol colored complex with ferric chloride. The phenol are identify the bromination products at certain ester and ether. The most acidic in nature is carboxylic acid, then phenol, then water, then alcohol. The spectroscopic analysis of phenol, which structure elucidation of phenol. There are three processes: infrared, NMR, or CMR. The further explanation, as we see in the uh, figure, the phenol shows strong band due to OH stretching in the same region 3200 to 3600 centimeter as alcohol. OH stretching strong broad, the phenol for alcohol 3200 to 3600 centimeter inverse. Phenol different from alcohol, however, in the position of CO stretching band. CO stretching strong broad. Phenol about 1230 centimeter inverse, alcohol 1050 to 1200 centimeter inverse. The phenolic ether do not of course show OH band but show CO stretching. CO stretching strong broad. Aryl and vinyl ether 1200 to 1275 centimeter and weaker. 1020 to 1075 centimeter. Alkali ether 1060 to 1015 centimeter. NMR, which absorption by OH proton of phenol like that alcohol is affected by an degree of hydrogen bonding and hence by temperature concentration and the nature of solvent. The signal may be appear anywhere in the range of delta 4 to 7, or if there is intermolecular hydrogen bonding, still lower, delta 6 to 12. CMR, the OH of phenol exert the usual effect of electronegative substitute. The conformity test. Carboxylic acid dissolved in sodium bicarbonate, fruity smell will be formed and bubble of gas CO2 is evolved. With the phenol is not react with sodium bicarbonate. No fruity smell form and no color will be formed. Thank you.